hope you guys know how good you all look. This is a packed house. And a lot of you probably know we actually sold out about 10 days ago. And some folks on the board like Marisa and everybody said we should have a waiting list. And somehow she was able to pull that off. That was a magical trick, by the way. Anyway, I just want to point out all these plants. If you get a chance to go to Plant World, thank them for doing this. Because every year they bring these plants in, and quite frankly, you know what this would look like if this was not green. And we're supposedly in the green industry, so give them a thanks. Check out the different tables out there with different vendors, because they really want to speak with you. Even if you don't know them or don't think you'll do business with them, just introduce yourself. A big part of what this is all about, Think Trees, is networking with people. So try to get to know some folks in this room that you don't know. A big part of what our next speaker is going to talk about in terms of diversity and the climate and all of this, we all need to be working together and pulling that wagon in the same direction. And that's to somehow overcome what we're facing. So this is a good opportunity at this conference to do that. But I'm talking too much and you want to hear the speaker, who is Dr. Neil Hendrickson. And I want to say he's retired. So when I introduce him, just remember he's actually retired, but he was at Bartlett in Tree Research Labs for over 20 years. He's a current president of the New Jersey Shade Tree Federation. He serves on the New Jersey chapter of the ISA, and there's a whole bunch more that's listed in your book. But remember, he's retired. And a lot of you out there I know are trying to get retired, so when you see him, that's kind of what it looks like. You still get to work, but you get to work in a field you like. So he's going to talk about the impact of climate disruption on trees and insects. So without further ado, please welcome Neil.
Thanks, Andrew. That's a lot of introduction, but basically what are you doing bringing someone from Jersey here to talk about climate in New Mexico? Oh, and being a retired person and a grandfather, I cannot let a bad dad joke go without throwing in another. So, and vegetables, yeah. So Mr. Carrot and Mr. Lettuce are walking down the street. Goodbye, Mr. Lettuce. Goodbye, Mr. Carrot. Mr. Carrot walks across the street, gets hit by a bus. The EMTs show up. Mr. Lettuce is standing there and says, "Is he going to be all right?" "Yeah, but he's going to be a vegetable." And most of the time, because Bartlett, the lab, is in the south, everybody was like, every morning when they came up, "How you all doing?" No, if you ever saw The Sopranos, yes, we all talk like that. "How you doing?" That's how we do it. Anyway, so I've spent the last 6 weeks, 2 months, trying to become an expert on your weather and climate. And all I know is that, all right, gentlemen in the back, there we go. I have dealt with a lot of climate skeptics, and and by the way, I have never been on a stage or had a venue with plants like this. These people really deserve your attention. This is awesome. Anyway, so if you don't believe it, sorry, I'm just presenting data. You can do with it what you want. But depending on how old you are, you may recognize this line. You may ask yourself, how did we get here? I'm just going to present a lot of data to set this up before I talk about all the bad news. And it's, of course, where I live in my town, when I do speaking locally and things like that, they always say, "Don't talk to Neil about trees." You're going to feel the same way because I have no particular good news for you. So anyway, what is out there? Well, if you all know this, but it's building on the basics is the theme, so that's what I'm doing. So that's where the carbon was over all years. This is the famous hockey stick. It doesn't look like it, but if you extrapolate it out, it levels out. The big spike, obviously, is since the Industrial Revolution. It was always 300 parts per million. They pull that up from ice cores where they take out the air. They pull it out of tree rings of all things, which is really cool. You're in the part of the world that does dendrochronology, which is the coolest science I can think of. So there's where it is now. We're up there. So there's plenty of CO2. And it all started around the time of the Industrial Revolution, when coal and then making steam and all that stuff came along. And it's just been going up ever since. Other fossil fuels, oil came around the turn of the 1900s. So I thought this was amusing. So and I do a lot of trying to go down alleys to look at old stuff to see when people figured this out. Well, people figured it out way, way back. But in 1912, as you see, we burned 2 billion tons of coal in 1912. That put 7 billion tons of carbon into the atmosphere. And as you see that line, someday, a couple of centuries out, it could be a problem. Yeah, a couple of centuries. But where's all this data coming from is Hawaii. And why? Is because it's nicely isolated and it gathers all and mixes all the world's air. So if you've never heard of the Mauna Loa Atmospheric Laboratory, that's where it is. And this is very famous work. So if you go back to when the data was starting to be collected in the late 50s, look at it just go up. So it's been going up pretty steadily, and it's a bit of a concern, because this is when I was in graduate school, and I remember going into a laboratory and having to measure CO2, and I just remember it being 320 parts per million. That was 1975, and yeah, I'm old, but I'm not that old. But now, last summer, and it goes up every year, as you see, last summer, now it went from when I was in school, 320 to 428, and it's going up every year. Each year is a new record. So as you see, it's that much bigger than it was last year. But all this fuss over such a little amount of gas, it has always amazed me. It's 0.04 of a percent. That's not much. Look at the pie chart. It's not much gas, but it's so good at trapping heat. And the molecule is really, really tiny, and yet as that sun comes in through the atmosphere, hits the Earth, and it comes in as shortwave and re-radiates as long wave, it hits these molecules and entraps it. Well, the only reason the Earth is habitable is because at 300 parts per million, it did it perfectly. Go figure. I'm not going to try to explain how that worked, but now it's a lot more gas means a lot more heat being trapped. And if you look at how much this is, it's not a lot. In a small room, I mean, there's the room and there's the amount of CO2 we're talking about. The background CO2 is blue, and what we've added is in purple. So it's not a lot. It's just amazing how reactive this stuff is. So, okay, that's CO2. But of course, because it warms the atmosphere, temperature has gone right up with it. So now as we look at it, for those of us who look at these sorts of data, look at what's happened. Globally, the last 10 years are the hottest. So it keeps getting warmer. And then if you follow the news on this stuff, the big threshold that a lot of us, and I'm not a climate scientist, I'm a tree guy. I just got interested because it affects trees, and I live it even in Jersey. And so when you look at this, the threshold was 1.5 degrees centigrade. Oh my God. Well, we just passed it. It's 1.6. And we're not slowing down. We're burning more. If you hear the story about data centers being built and needing energy, well, they're going to need a lot of energy, and there's not a lot of other energy out there right now to run them. So other than fossil fuels. So yep, in this country it was the hottest year on record, as you see there. Oh, by the way, this slide came from Climate Central. And there are a bunch of scientists in Princeton that seem to spend their lives making PowerPoint slides for me, because I use them all the time. I don't see other people using them when they do talks on climate. And every time I need one, I go to Climate Central. So most of this talk should be credited to them. But I learned this in school, and some of you with enough gray hair or none left at all might remember this, that in the 60s, yes, I go back that far and farther, there were these 4 laws of ecology, and they still hold up. So if you think about this, they're really only one. And that basically is everything is connected to everything else. Everything must go somewhere, which is kind of the same thing. Nature knows best, and there's no free lunch. I'll come back to this a million times whether I say it or not, if you look at things, because the fact that everything is connected to everything else, there's this great concept that I didn't know much about this. I read a book. I still don't understand all the details of it, but it's called chaos theory. And what it means is just a very small change over here can produce a very big change over there. And it started with somebody doing a computer program on weather. And it just means that the system is very sensitive. So going back to what I said about small bits of CO2, the system, the global system, surprisingly enough, is tough. It's big, but it's still sensitive. And the more we add of CO2 and the more increase in temperature, the more sensitive the system is and more prone to change. And so this just illustrates that everything is connected, right? Everything has to go somewhere. If we make more CO2, where does it go? If we burn more fossil fuels, if there's less rain here, where else is it going? That's all that means. The big word, though, is feedback. And that means that these small changes change something here, and they come back around. So these are just a couple of slides to say it's not this simple. And the reason the climate critics go so crazy saying, it's just climate scientists don't know anything, try to model the entire world's climate system. So if it looks like this, that's just a tiny little fraction. I just put these up to say everything is connected to everything else and everything must go somewhere, and there's no free lunch. So all these things, each little change in one causes a change in another and another, like this. These are just small little models of small parts of the climate system. So when you go and you look at sources like I do, Science Direct, and this is what they're saying. The feedback loops are going to get us. And if what you might not have here, you folks are far more civilized than where I come from, because our front page news says stuff like this. You know, I mean, granted, our New York Post is known for this, but I gotta love this stuff. You know, we're massive climate catastrophes. Well, that's because it's New York, and that's how, or New York, if you want me to say it that way. But same thing, climate central graph, just that small changes are going to produce bigger changes. We're going to get more extremes. And I have to thank you folks for bringing in the perfect setup, because having 70-degree weather here while it's winter in New Jersey is like, really? Thanks a lot. Because usually the first week in February, it's not this nice. I could stay here a while if it's like this. But I hear you're going to get semi-weather, but you're supposed to get rain, but like us, you're not getting enough, but I'll get to that. So anyway, in other words, it's not unusual. Now, some of you folks may have this suit in your closet. I still do. I just don't take it out very often. But it's not unusual to see these extreme events. So that's kind of nationally and globally. So when I started trying to learn what you folks have to deal with, I brought it to this level. And then I was surprised to see you also, just like anything else, had the warmest decade in history the last 10 years. And the last time you had temperatures below normal, as you see there, was 1992. You might have on average, but I mean for the year. And if you look, and again, Climate Central is our friend. They'll narrow it down to your area, which is a beautiful thing. So what you could see is you're getting a whole lot more record highs than you are record lows. Not that you don't get them, we do too. And it's a big scatter diagram. There's a lot of noise around the trends, and you'll see that too. But if you look at it here, this last year, 2024, was out of 130 years, was 129th. So it's the second warmest year you ever had. So I'm starting to prepare this talk, and it's getting my attention. So then I start looking, and hazard ratings. Yep, you're way up there on increased heat. I'm always curious because your drought is high, your risk of drought is high, but not as high as I thought it would be, considering it's a pretty dry. You're getting 9 inches a year on average. And you could see the others, but what does that all mean? That means basically, and here's where it really comes down to all the things that you're going to have to deal with plants. And Andrew and I had a lot of conversation just before this about how do you manage these concepts of the changing seasons. Well, what's happening is summer, for example, is getting longer. We are getting warmer, longer summers. You probably know this. You probably feel it. It might not be bad. You might like it. In Jersey, I like warm weather rather than cold. But we've had a miserably cold winter. Go figure. Polar vortex, we call it. But what's happening is you're also, this will bring your average up, this kind of weather. So it's not going up much, but 3 degrees Fahrenheit is a lot over your winters. So that's pushing either season. It's making winter shorter and warmer. And and that accounts for 13 days. So almost 2 weeks more, less winter. Goodness. But that also is accompanied, as you might guess, with less snowfall. If it's warmer, it's going to fall as rain. It may not fall here either. It may go somewhere else. I mean, the South just had a huge snowstorm, if you read that, the Southeast. They had huge amounts of snow, totally unnatural. But it probably came from here. Took your evaporation and moved it there. Everything's connected to everything else. And, of course, go into spring, and I look at the color of the boxes. You're between 3 and 5 degrees warmer in the spring. So spring is coming earlier, and you've got 23 days more spring, which is great if you want to grow things, if you have the water. So, and it also means your snowpack, on which apparently you depend fairly much, you're getting less. We don't have snowpack in New Jersey. We make it for the recreation areas. But this would be, so as you can imagine, I'm working on this talk, and it's saying, whoa, this is serious stuff. These people have some real issues. Then you go to summer, and I'll talk summer a little more, because it's now longer and everything else. And there you are up at the high end of that, too. And when I get off of your local media, it's one of the fastest warming regions in the United States. Congratulations, it's good to be first. But dubious honor, I might say. But again, look at the scatter of the data. This is why it's easy to argue with it, because it goes up, it goes down, but it's creeping up. And when it's 27 days above normal, that's warm, and it's a long summer, which can be nice if you like it. But here's the other thing, and this is where plants come in. And I never thought about this until it became an issue of climate. But it's a bigger issue than I thought. When nights are near 70, and this is essentially the same graph, but it's compressed, so you see how many days the evenings are above 70 or near 70. Why do we care? Because of plants. These warm nights are pulling out huge amounts of moisture out of the soil, which you can ill afford, and through plants. And some of it will fall as rain, some of it will fall as snow, but mostly now it's going to shift to rain. And if it's pulling it up out of the ground, it may ship it elsewhere. It may go to the southeast or up towards the Great Plains. So this is the graph, though, that always got my attention. So if you look at the way temperature and photosynthesis works, as temperature goes up, so does photosynthesis. You see that graph goes up until basically photosynthesis stops. It's like, I'm done. It's too hot. I can't run the system. On the other hand, respiration keeps on going because it's got to keep the plant alive. It's got to cool it. It's got to run its metabolism. It's got to grow because unlike us, plants got to grow or die. So as you see there's this is growth, maintenance, all the good stuff. Well, as it gets warmer, it decreases. And if it keeps getting warmer at night and you have these prolonged periods where the tree, what they call net primary productivity, when that goes to basically zero, then the plant just goes away. We have in Jersey, we can grow a lot of Western plants we used to grow, Colorado blue spruce. We can't grow that. We can't grow Doug fir, inland Doug fir, we can't grow that. So a lot of plants we can't grow. Sugar maple we can't grow because it's now too warm. White pine we used to grow, we can hardly grow that for these reasons. So what happens is, this is just an aside, you might not know that of all the water a plant takes up, 95% is just cooling the plant. Transpiration, only 5% or less goes to photosynthesis. So this is why having water is such a big deal. And again, I said this already, the evaporation here might go somewhere else. But the big story and the good news is, all I'm going to do is give you bad news and make it miserable. And then the next talk, she'll solve the problem for you. So it'll be great because I can absolve myself of all responsibility, which is what we do in Jersey. But again, this isn't Climate Central, but you're supposed to be still getting less. So it's not getting better, right? So follow this here. And it's more variable. Even in Jersey where we have 41 inches of rain, on average, historically, it used to fall nice and evenly over the year, and it was a beautiful thing. Now we get about 10, 20 storms of 2 to 4 inches a year. It's insane. We get flooding that we never had, and erosion we never had. And this is what's called the aridity index. Just the darker color means it's getting drier. The evaporation is greater than the rainfall. So it just means that if you look at the column on the right with all the colors and look at the color, it's getting warmer and it's getting more arid. Your arid southwest is getting more. And as I just said, your rainfall's not getting that much more intense. These are hundredths of inches per hour. So it's not that big a deal, but it's changing and it's going up. It's a trend. And I already said, snowpacks are melting, but they are also smaller when you have this thirsty atmosphere pulling it up with warmth. You're not getting the snow you expect. And, big deal that you're not getting the tourism, which I don't know how much you count on, but I would think you would. And as far as agriculture, same story. You're going to need to water. And if you're watering, where's it coming from? So I started to look at that too, and I see that you're, and by the way, James Cassidy, I had him come to our conference. He's a speaker here. You got to hear him. He's the best speaker you'll ever hear. He's funny. He was a bass player in a band. And he's the best soils talk I ever heard. And so your soils are going to be, as I've said, dried out. And I just decided to pull this up. This is the last data I could get for this week. And you can see, nothing I'm telling you is nothing you don't know. I'm just trying to put it all in one place, is that, yeah, you're in a drought, or a lot of it, and you can see you're go from abnormally dry to pretty extreme drought in the southeast and south. So, and I look at this and said, oh, well, it's nothing new. You've always been like this. It's the dry southwest. It's the way we describe it in the northeast. But when I look at it, it's like, yeah, there it is. But do you get used to it? I guess you do. You wouldn't live here. You wouldn't all come to these conferences. It must be pretty common to be putting up with this. And I'll talk about that a little more. And of course, one of the things I know is that you've got a kind of important river that runs through town, and a lot of through New Mexico. And so I get these things from your local media, your universities, and things like that. And yep, this is going to be a big deal. You're going to get more droughts. You're going to get bigger floods from the bigger, more rare events. And then if you're going to pull more out of it because of the water elsewhere, that's going to be a big deal. It'll change the quality. And so I also read this. I don't know who Danielle Prokop is, but she writes really well on the subject of your climate. And, this is, there it is, about the snow melt. And the same thing, bigger, more extreme events, less of them. And so I was also talking to George Duda outside, and I said I'd mention this because he was talking about it. It's what he did. Where I live, my old forestry professor used to describe the northeastern hardwood forest as the asbestos forest. Doesn't really burn. We have the pine barrens in Jersey which do burn like the West does, but even then we have more rain. And our fires are typically 4,000 acres if they get massive. They don't get much bigger. And that just basically is kindling out west. So anyway, yeah, you're getting more fire days, 41. I'd be a little concerned. I heard him mention it on the news this morning that you have fire alerts here and there. And of course, if the rivers are a problem, so's your groundwater. I didn't know this. Did you know this? Is this common knowledge that that your rivers are the most endangered in America? I thought that was pretty extreme. But anyway, the pressure's on your groundwater. And I know people are working on this. I haven't got time to talk about what's going on, but it's a big deal, right? Everybody's got the issue of water, and especially all kinds of plants, whether it's agriculture or others. Climate Central. Yeah, look at all the red. You've got lots of that says you've got groundwater issues. So that's a lot on summer, but you can see none of this is changing. Don't ask Neil about trees. Don't talk to Neil about trees for that same reason. It's warming, and you're getting more days, right? And here's the other part. That means the first freeze is later. So your growing season is longer, which is great. You could grow all kinds of things, trees, crops. You can grow anything if you have the water. So, and I'm really impressed by the number of nurseries that are advertising here and the number of plants they offer. And I'll touch on that before I'm done. But one of the things that's changing, and one of the conversations I was just having with Andrew, was just that, what do you plant and where? Because look at the change in the plant hardiness zones. It went from, where I live, I used to be in a 6B, 7A, and I think still am. But look at these things jump a whole class to 8As because it's getting so much warmer. So specifically, let's narrow it down. What could I find out? This is what we use. We say this a lot. Trees take time. So the idea is it takes, as Andrew was saying, it takes so long to get a tree ready to produce and install. If you're a grower, it takes years. You got to test, you got to do this. What you're going to end up doing is experimenting. You're going to stick plants in the ground and hope they survive. And that's what we're talking about. And all that I'm saying about everything being connected and everything else, trees live in the averages and die in the extremes. So if you get this warm weather and no precipitation, that's really, really stressful because that respiration is going on in the roots underground and things like that. If the environment changes faster than the plants can adapt, they're going to be stressed. And if they're stressed enough, they're not going to survive. So, you've got wildfires, and whole communities are changing, right? I'm kind of alluding to this several times already. And if you can't tolerate it, they'll just either disappear or they'll be overtaken. I had no idea that you had Russian olive. It is the scourge of our woodlands. So we have a disease called beech leaf disease. It's killing every beech that's in the woods. And so beech and ash trees are all gone. So we have these gaps in the woods because those are two major species. And what's coming in? Russian olive. Everywhere. Can we get rid of it? No. Does it spread? Everywhere. It's the most amazing plant, and it's kind of pretty, but people planted it because it was. But anyway, the tree line is going to move up the mountains typically, and on and on. So your tundra ecosystems, wet, higher elevations could be a problem. So when I was in school way back when the dinosaurs ruled the earth, there was a terrestrial ecology class I took. And they described all this stuff, whatever the cause. They didn't talk about climate change back then. And what they called it was ecosystem simplification. It was not uncommon to find, let's say 13 species on a given acre of hardwoods. And now it's sometimes half that. Nobody notices because it's green. And that's what you face all the time. the world out there, nobody notices what's growing if it's green. So for us, our woods, are mostly Norway maples, invasive. And people say, well, it's green, it's beautiful. Turns yellow in the fall, stays green late. So anyway, your pinyon pine, one of my old favorites. When I took dendrology, you can see the way the change in the likely suitability of where it'll grow. And of course, the Forest Service says it could be gone. So, as I was going to say, you get as it gets more arid, get more changes. I mean, I keep coming back to the same subject. And what really struck me is when I thought, well, at least your bosque forest, which is a term I never heard until it was referred to here. A bosque back there is a landscape architecture term that kind of means a really well-organized little square of trees. But your riparian forest, as we call it, I had no idea it was under that much stress from the fact that the Rio Grande is under stress. So, the fact that they might not be coming back when cottonwood is like your major species. So it's really, it really struck me as a big deal. And now that you get fires in those areas, this is all news to me too. Well, for those of us that live in the burbs, as we'd call it, or near cities, now it's different. I've kind of talked about a broader picture for everywhere, the whole state. What about your lot in town? Here's those things all put together, focusing on, say, a single plant. So you got the moisture extremes, the temperature extremes, more CO2, and now I've talked about the changing seasons. And then there's a plant response there. And there's lots of ways to describe that the plant doesn't know whether to do this or that. But basically, it doesn't know how to respond, and we don't know how the plants are going to react. Especially now, among the talks you're going to hear is about pests and disease. Well, I'm curious too. I'm going to be here for those talks because I can't imagine what's going on, and I'll talk a little bit about pest development here, because there's also natural enemies. So when you look at that, sorry fellas, I just messed up. There it is. So if you know this or don't, insect development is linear with temperature. So on a day like this, I mean, in Jersey, our big thing is ticks. So you get a day like this back there and it's wet, and you're going to get ticks because they're out. They will become quiet when it's cold, and they come out when it's warm. One of our biggest issues is the various ticks we get. But if you look there, you can see it just goes right up with temperature until it gets really, really warm, and then it doesn't. But what does that mean? So for example, if this is the way plants flower, and they function on day length, which they do, and they flower. And in our case, there's a whole bunch of spring flowering plants. And we always expected our pollinators to come out with them. But if it's warmer earlier, they come out here. And they completely miss the plant. And so the whole issue of bees, pollinators, all those things are a bigger issue than they ever were. And it's not uncommon. The other thing is if there's a beneficial insect that takes out your bad insect, which there always have been, they used to be timed together. But if one is asynchronous, not quite in time with the other, you can see what happens is the pest explodes and the beneficial insect doesn't have the insect that it wants to eat handy. It's already done all its work. So it could be days, weeks, but you can see as these seasons change and by so much that these effects can be quite real. And a lot of entomologists that I've listened to have talked about just this sort of thing. It amuses me no end that that when I looked at one of your websites, do you really have the emerald ash borer here? Amazing. I saw it when it was first identified in Massachusetts, and college kids took a big pool skimmer and pulled them out of the trees for us so we could hold them. And the company I worked for, Bartlett, made millions because we injected them and climbed them and identified them. As far as we knew, I haven't heard about it in, I don't know, 10, 15 years. And I can't believe you have it. Do you have the emerald ash borer around here? You will. It moves, and it moves everywhere, and it moves fast. We move them. And so there's whole talks on that. But it'll get here because you have a lot of trains and trucks coming in and out. And you will not have a single Fraxinus of any kind left. And there's only two kinds of treated ash trees in the Northeast, and that is treated or dead. And there's such an overwhelming supply. And by the way, Louisville slugger and all those things, there's a reason they're using sugar maple now for baseball fans, as you can't get ash. Their big stands of ash have long passed. So this is the one that amuses me too. I am here today. I made a wonderful living simply spraying gypsy moths, was what they were called then. They're now called spongy moth, with 7. Before we knew there were better things. But I look back at some of my ink check stubs and I said, oh my goodness, the only reason I could feed my family was this gypsy moth. I love them. But they're gone. We don't see them. And last, this kills me. Do you have this? Well, don't worry about it, because people were apoplectic when we got the spotted lanternfly. And there were people doing all kinds of insane things, and tree companies with no morals or ethics were claiming all kinds of treatments. It was insane. And then a year later, they were gone. And the reason is, if you've ever seen one, they are one big, fat, proteinaceous meal for a bird. And they might not have tasted great, oh, wait a minute, there's a commercial here. Tastes great, less filling. But they definitely will give you a big proteinaceous meal. So same thing. They were here. They're gone. And people say, well, what happened? No, they got eaten. That's the way the beneficials caught up with them. So all these terrible insects are pretty funny. But then I was looking at, what are your big issues? I see that you have a Chinese elm there. But the issue to me is not the weevil damage. I haven't got time to go into this. You too, huh? Because I came in from the parking lot yesterday, and I see this sorry looking, I think it was either crabapple or hawthorn. I didn't even look. I walk up to the tree. I rock it back and forth. Great planting job, folks. People from Jersey must have taught you well. Because if you can't solve this problem, and I'm not going into it, it's not what I'm here to talk about, but if you can't fix this, that predisposes plants to everything else. You want to weaken a plant and make it susceptible to everything, go ahead and plant it deep. And then put rocks around it. Anyway, hey, I can get rolling on this, but it's not what I'm here to talk about. But anyway, the issue is, as the pests that you do have, and I'll be interested to hear what they are, the plants become more susceptible and they can't defend themselves. And as I said, they're linear with temperature. So what's happening is plants that died in the winter, insects that died in the winter, didn't overwinter. They overwinter. And so I remember we'd get done treating for all kinds of insects at the end of the year, and it'd be great. And then there'd be more generations towards the end of my career. And it was like, whoa. And it's like, yeah, welcome to a climate change world. And so again, and multi-generational insects will keep coming. I cannot believe it in a dry climate, but this came from your media. Bless you, are you getting more mosquitoes? How is that possible? You must have little buckets of water and Coke cans laying all over the place. Because, we get it, and now we're getting these West Nile virus, all kinds of horrible mosquitoes, the Asian tiger mosquito. I don't know, you haven't heard of that one, but that'll get you in the daytime, the nighttime. It'll sneak up on you. It thinks, and it's just nasty. So anyway, again, number of generations per year go up, And as I said about trees, their insects can adapt in a generation or two. They turn over so fast. Trees can't do that. And if it said there, the heat island effect, not that this is a great big city, but anytime you have pavement and parking lots, I noticed this coming in on the airplane yesterday, is there's a lot of black surface, a lot of paved surface around here. And that'll raise the temperature even more around the surrounding areas because soil is better than pavement. So, all right, now what? All right, so I started looking at who's doing what to make things better. And all the evidence is around here. I see all these nurseries with all these plants. I'm so impressed. But what I wanted to bring up that this slide says about let's plant Albuquerque, and I use Albuquerque because we're here. I know some of you are from elsewhere. But the list is, for example, this diversity. Well, diversity is actually the answer. That's why you plant something, it might not live. Plant something else. Don't plant all one thing. What if something happens to cottonwoods? Right? I mean, your key plant that's a really tough one if you lose that. Willows. We've occasionally had willow leaf beetle back east, but it was never a big deal, but willow's not a big plant for us. And there was another plant, I can't remember which is a big one for you, but this is very common. The 10, 20, 30 rule was brought up in the 70s by Frank Santamore. Don't plant any more than 30% from a family, 20% from a genus, and 10% from a species. If you look at the literature on this stuff, it's almost impossible to do. Nobody has really been able to pull this off. And so one of the speakers coming for our Shade Tree Conference is a guy, I can't pronounce his last name. I refer to him as Cecil Unpronounceable. But he's Dutch. And he came up with a different rule. So if you haven't heard of this, this is a complete aside to my talk, but it is the 3-30-300. And if you can read that, can you all read it or do I need to read it? But you should be able to see 3 mature trees from wherever you are at any time in your town, your neighborhood. And you should have 30% tree cover. We're dreaming in a lot of cases, especially around here. But this is ideal and this is global. It's a rule of thumb. And you should be able to have a park or a green space or something. I looked at a few yesterday. Marisa sent me some places to look around. Yeah, you have some gorgeous parks with some big trees. It's really nice, but they're not necessarily within 300 yards of your home. So that's the new thing that has come up in conferences. So if you're interested in planting trees, if you're responsible for planting trees, 10, 20, 30 is really difficult. Try getting close to the 330, 300. It's just a guideline, it's just a new thought, but it's kind of sweeping the horticultural world. And it is the way to get this diversity, which is the way to around climate change. So I looked at what the mayor said, and if you read down what you see, that you're not only losing your canopy around here, but if you see that magic number in the last line, it's less than 10%. This is tough. You've got a lot to do around here if you want to make this a greener, nicer, sustainable, and I hate this word sustainable, been around forever, but you know what I mean. And then I look at these things, and you've got, as I've said, I'm not going to start making an eye chart out all these slides, but the point is somebody went to a lot of work. In this case, the Nature Conservancy had said, look at these, look at all these different locations where you need to have stormwater issues, where you have really xeriscaped areas. What do you plant? And then there's these lengthy lists and descriptions of the sites. I was so impressed to say somebody has done their homework and they're really thinking about this. So I hope if you're responsible anywhere for getting trees in the ground, that you see some of these trees that these people are listing. And I saw a nursery list out there. It's just as long. I see this. And you can grow some pretty cool stuff like we do. We can grow, one of our coolest trees is Kentucky coffee tree. We grow crepe myrtle now because it used to grow in the South. Now it's warm in New Jersey, so we can go crepe myrtle. On and on and on. So you've got a lot of cool trees. Accolade elm, I have one in my front yard. It's a cross between Chinese and American. It's the greatest single tree I've ever seen. It's so bulletproof. It doesn't care about anything, drought, wet, and it's beautiful. So if you can grow these things, for goodness sakes, and I see this other websites. So you've got people that are doing a lot of work to try to get the green cover, the canopy cover around here up to do something about this enormous climate change issue. And then, of course, I did not know this till I started working on this talk. We always knew in the pest management part of work that we went to IPM and then we called it plant healthcare, and there was this pyramid. And so I'm happy to see one vendor outside because now we have, by the way, climate smart pest management. The stuff we didn't know about, it was all reactive. But now there's all these data that I just presented that they're incorporating into how to do pest management. So I thought, well, that makes perfect sense and I'm very impressed. But I cannot do a talk and not mention this. The issues that we can deal with culturally are always critical. And so as I drove around and looked at the urban forest of Albuquerque yesterday afternoon, I realized that there's one thing. People are really afraid of having things like mulch around their tree, but I'll get to that. This is cool because for years I was saying you don't need to be fancy about looking for soil moisture. You need a long screwdriver. I still carry a couple around. They're about that long. And you just probe the ground. And I was doing a field demonstration once, and it looked like that. That's all you need to see if it rains, how far did it get down? And then you check it. And the guy said, that's nature's dipstick. And I thought, well, that's really cool. I agree. It is. It's just like a dipstick. Although the cars I have don't have dipsticks anymore. Nobody knows what they are. And the other thing was mulching. It said, be sure your trees is well mulched. Oh, did that get my attention? Because I looked at mulches to see, why don't people mulch? And I was told they're afraid of fire, they're catching fire. So I found a website where somebody in Nevada, I think it's the whole Nevada Forest Service, put all these mulches out and set fire to them, which is great. This is why arboriculture is the best science. You know, you do stuff and you set fire to it. So here's the materials they use. And my favorite, where I come from, it's the answer to everything, is composted wood chips. They wouldn't burn. Smoldered, but they wouldn't burn. So for those of you who have, or if those people you know, if you're out telling people about no, mulch will burn, you don't want that near your house. And I've heard that, get all the material cleared within so many feet of your house. Well, not mulch. It's not gonna burn very easily, if at all. So that's a good thing. And so, and biblically, this was an old quote. Money is the answer for everything. And I look at it this way. Mulch is the answer to everything. Oh, really? So there's some disciples in there. Well, I'm glad to hear it because you had Linda Chalker-Scott here who recommended I come here. And I know Linda and I have been saying the same thing. I gave her this line that I still use. Save your questions to the end of the talk, and no matter what your question is, the answer is mulch. So Linda liked that. And so anyway, it does all kinds of things. Well, we have grass. You don't, so forget that. But it reduces compaction, conserves moisture, which is so critical here. You get a heavy rain event. Suppose the rain event now comes not as a light rain, but a heavy rain once in a while. You don't want it running off. You don't want it causing erosion. The chips will hold it. And if you do get an event like that sometime, see what happens to your chips. Pull them aside. Check the soil underneath. The chips act like a gator bag or if you look up gator bag you go to a Gucci website. You go to TreeGator, that's the right one. But as it breaks down, the microorganisms in the soil, you don't need to fertilize so much because they'll break it down. It's the best thing for the soil. All trees come from some kind of woods somewhere, and where they grow is in a mulch. So, and not only that, where I live, the two worst pathogens for trees are weed whackers and lawnmowers. And if you put mulch around the tree, they won't do it. If you've never heard this, if you have anything else, in this case it's grass, but if you don't have mulch, plants don't like it as much. In this case, it was turf. So if he put mulch down, he got 5 times the growth in 3 years, right? The crowns were larger, the bottoms were larger. And this is one of my favorite lines to wrap up with. I thought I'd go a little longer. I'll have time for a question if you have it. But this is one of my favorites. I like this so. That they didn't know really what was going on, unlike people in the green industry. And it limited their choice. I mean, back in California, the big thing is brown is the new green. Everybody wanted lawns. And a few years ago, I did talks on how they were painting. Lawn care companies were changing to lawn painting companies to keep it green. I don't know if you were familiar with that. But this is the quote of the century. Anyway, so, or you can get just used to it. Because no matter what we do, we're not doing anything to change anything too dramatically. So I'm afraid this is where we're going. We're just going to have to get used to it. So thank you. I am done. Yeah.
Raise your hand if you have a question.
I know I depress people so badly that all they want to do is go and get a coffee and say, I don't want to hear any more of that.
We have 2 microphones that are circulating if you raise your hand. Or are there any online questions? Yeah.
Yeah.
Could you repeat the question?
Yeah, the question was, I've heard that carbon helps plant grow. It's actually the CO2, because plants, obviously in photosynthesis, take in CO2 to make starch and carbohydrates. But what they also need, so if you enhance CO2, and I saw this, did a lab class on it, what happens is as you keep taking up CO2, the plants grow. What else do they need? Water, nutrients. So there's pretty good studies that refuted the idea that just enhanced CO2 will help, because everything is connected to everything else. You take up CO2, you're going to need to take up more nitrogen, more of everything, more of all the nutrients, and more water. So it's, unless you provide everything, and then a plant will just max out. Even if you could provide it with everything else, there's only so far past it can go. Any other questions? Well, you get to go to break a minute early. Oh, sorry.
On the slide you had about comparing different mulches, what was the flame or flame resistant?
The question was, what mulch was more fire resistant?
Oh, sorry.
It was arborist wood chips out of the back of a truck.
Okay.
And I talked to somebody, and what did they say they were chipping? Oh, Austrian pines was this people outside. I said, what are your chips made out of? We gave up on Austrian pines years ago because of something called Diplodia tiplate, Sphaeropsis. But Linda used to talk about this too, and she had done research, Linda Choker-Scott, that whatever comes out of the back of a chip truck is the best mulch because it's the closest to what the trees grew in. Now, I have a colleague at Bartlett who he loves using willow You know why? It's salix is the Latin name, salicylic acid. You put down willow mulch, and it functions as a deterrent to disease and insects because it takes up the salicylic acid and protects itself. So he started to do work on different mulches, but that's the one that seems obvious, and it turned out to be true. So if you've got willows that died from drought, chip them up, put them around your trees because they're likely to provide benefits for pest and disease resistance.
Thank you.
Yeah, thank you. Thanks so much.
Sure.